Okay, we're going to get started with the next talk. This room is sponsored by Rubicon. Rubicon Project has engineered the Advertising Automation Cloud, one of the largest real-time cloud and big data computing systems. The company's mission is to automate the buying and selling of advertising by offering innovative products to connect buyers and sellers globally. For more information, visit www.rubiconproject.com.
It's always important to talk to the sponsors.
We have a request that you fill out a survey form for the speakers. It's on the same card as your name badge. It's got a little barcode and a URL. We appreciate that. That feedback helps us shape future skills. Okay, this talk is on nginx 101. Now with more Docker. She paid me to say that.
I did pay him to say that.
Our speaker is Sarah Novotny, and in this talk, Sarah will cover the three most basic use cases of static content delivery, application load balancing, and web proxying with caching, and she will touch on Docker containers. Without further ado, I give you Sarah.
Thanks so much. I totally did pay him to say it that way because it's a shameless marketing ploy. I'll admit, I also have to tell a bit of a funny story. I was asked a number of times for the slides for this deck so that someone could look at them and try to find out how to pitch how nginx really works with Docker and really innovates. And I'm like, well, that's kind of like saying, how does it work with Red Hat or CentOS? Or there's some ways that are nifty, and we'll touch on those. But it is just another way to deliver assets with Docker for us. So, how many of you have heard of nginx? You're here. Hands up. All right. That's 80, 90% of you. Awesome. How many of you run nginx? It's about 50%. That's pretty good. How many of you still think you want to know the very basics of nginx? Middle and so I might have some trouble here later. nginx, of course, is run by about a third of the sites on the internet at this point. We're super proud of that. And we are now delivering content for 44% of the top 10,000 websites by traffic, according to the last month's or this month's W3 Techs report. nginx is at its core an HTTP server that also does a whole bunch of stuff around application delivery and acceleration. So we really like to think of it, and I can tell you stories of the early 2000s where it was sort of a secret handshake if you knew about nginx, because you had to know how to spell it when documents were still all in Russian. We think of ourselves as the secret heart of the modern web. If you're watching video pretty much anywhere other than YouTube these days, it's coming through nginx. If you're going to big websites, it's coming through nginx. And there's a reason for that. We started as an open source project in 2002. Igor Sasayev was working at rambler.ru, and that's roughly Yahoo in Russia. And he had a problem, as many sysadmins do. He had not enough hardware for the users, not enough time, and not enough resources to make it scale, but he had to make it scale. So ultimately, he wrote a bunch of modules and plugins for Apache and found that that didn't end up scaling as well as he wanted. So he threw out the whole kit and caboodle and said, I'm going to write it from scratch. His fundamental goal was to be able to serve 10,000 concurrent connections from 2002 hardware, which for the record is less than what we carry in our pockets today. It had to have a very low memory utilization, very low CPU utilization, and be able to be super predictable. So what you saw in a comparison, or what you see in a comparison between Apache and nginx is with higher concurrency loads, you have, or with higher concurrency loads this way, you have fewer requests per second being moved through the server. You find that it gets bloated. It's not nearly as good when you have very high concurrency, very high throughput. And another challenge you have with Apache, because it's a thread-based model as opposed to an event-based model, is every single connection that comes into Apache forks off another thread and consumes more CPU, consumes more memory, and so you see up and to the right in not so good ways in this case. Whereas you know exactly what nginx is going to do because we are based on a different model. We're based on an event model. Now, Apache is great. I love Apache. I grew up on Apache. I cut my teeth building and running Apache servers. I even got to nurse an Apache server through being mentioned on Jon Stewart once. I would never recommend that. It's really not a problem right now, but once upon a time it was a very big problem. But Apache does everything, and that's great. It's very useful. But nginx sought to solve this very small problem. And Chris Lay gave us this great quote. Apache is like Microsoft Word, has a million options, but you really only need 6. nginx does those 6 things, and it does 5 of them 50 times faster than Apache. So considering Apache, nginx, you're going to make a decision. You want to try nginx, but we have to look at what sort of, we have a couple of things to ask. What sort of choices we need to make ahead of making use of nginx? What functionality do you require? What branch or type of branch or repository do we want to use? How do you want to install it? So nginx exists as a few things. nginx is an open source project. nginx has a third-party module community. Those modules need to be compiled in. There's not yet a pluggable module interface. That's coming. Thank you, thank you. That's been one of the big things I've been pushing for. It's coming. I can't give you specifics beyond that because, you know, any roadmap may contain nuts. But there is module functionality, or there is pluggable module functionality coming in. So, do you want to work with the open source project directly? Do you want to compile in any potential third-party modules for additional functionality? Are you interested in support services and a supported binary and additional functionality that nginx, the company, supports as well? So that's the what functionality do you require. How many people knew that nginx had a company around it? Ooh, even fewer, just a couple. Okay, so let me digress for 1 second then, because I do get paid. That's why I'm wearing a bright green shirt. nginx as a company was founded in 2011. It is the core group of open source developers that have developed and brought you nginx open source. About 95% of the commits in nginx open source come from developers that are employed by nginx. And on top of that, since the founding in 2011, we've actually accelerated the rate at which we've added features and completed bug fixes against nginx open source. So we're super, super committed to open source. Please don't think that the company exists to kill it, change it, make it different. We're super committed to it. In fact, in the US, I was the 3rd hire as an open source evangelist, liaison, community person, and I think sometimes. So, moving away from the company. The second question we ask is, what branch do you want to know? So how many people, some of you said you were running it. How many people are running 1.6? A few. How many are running 1.7? A few. That's a lot less people than said they were running nginx. So a lot of you don't know which one you're running. That's an interesting point. Lower. Ooh, 1.4. What? 0 point something? 1.0. Okay. We're gonna leave him out of this. We recommend you run one of the currently patched and modified code bases, which would be mainline, which is 1.7, and or stable, which is 1. Mainline and stable, they're both considered stable releases. 1.6 is stable in the sense of we are not developing any new any new features on it. It's not going to move. We're certainly not developing any new bugs because we're not putting new features in, but we are backporting bug and security fixes to it. The bug fixes are at our discretion. Mainline is where all of the core development happens, and it is actually where we cut our commercial products. So we believe it's stable enough to offer to our customers as well. So it's something older. The next question that we really have to answer is, how do you want to install it? So there are lots of ways to get nginx. As I mentioned, you could be compiling your own. You could pull official supported binaries of open source from nginx.org. Lots of operating systems now have it in mainline. Ubuntu has it as the default HTTP server now. One of the BSDs has it as the default HTTP server. and it is also in, I believe, one of the extended repositories for Red Hat 7 and RHEL 7 and CentOS as well. So you can certainly get it from your distribution. You can also get it from, because we're not all putting our own Linuxes on things anymore, or BSDs on things anymore, you can get it from the Amazon or the Azure marketplace as well. So if you want to just run images in AWS or images in Azure, we have images that are officially supported from there. We also have one of the top 5 Docker repositories as far as the most downloaded repositories that exist in Docker Hub. We have more than 2 million downloads of our base image. So I'm going to first go through the traditional install, which is super fast. It's 2 slides. And then I'm going to go through a bunch of the use cases as far as configuration files, walking through and doing a bit of translation between Apache and nginx languages. And then from there, I will touch on how you can also run it in Docker. So the traditional install, I used an Ubuntu or a Debian install here. We do sign our repository and sign our packages. So you start by pulling down the keys for that, adding our keys, and then going ahead and adding us to the repository list for sources for apt. Then you can run an apt-get update. It's really straightforward. I believe you guys have probably seen these once or twice before, something like this, somewhere. Yeah, okay. And then install nginx. Off we go. So that actually starts up the binary for you automatically. And to verify it's working, it's pretty straightforward. Nginx status, turns out we're running. It even says so. And then we go ahead and look at what version it is. In this case, this is an old image from me. It's 1.7.1. We're currently having 1.7.10, which was released just, I think, beginning of February. You can also navigate off to a web page, use curl, that sort of thing. In this case, you will find the Welcome to Nginx page. You'll also probably find this across the web when you find misconfigured servers, because lots of people who use very fast servers, lots of people who put up very small servers and don't necessarily do it as well as they could have also use nginx. In fact, we get calls as a company from people who have no idea why they're getting this error message, and that makes for an interesting conversation. The basics of the install, this also follows a pretty standard pattern. You guys should have run across some of these things before. Our executable is user-sbin nginx, really straightforward. Configuration files are in etc nginx as a directory, and our log files are var log nginx. Now, I mentioned that Apache and nginx are fairly different in their architecture. And I talked a little bit about how Apache forks off a thread for each connection. And this ends up consuming a fair bit of memory, a fair bit of CPU, and it scales linearly with the number of connections. So you want 10,000 connections, you need 10,000 times the memory of one connection. nginx is event-based. And this means that we have one master process and a set number of worker processes. Now this is configurable, but it's really not until you get to the very, very high end that you need to configure the number of worker processes. The master process is what evaluates the configuration file at the beginning and forks off work to the worker processes. All the worker processes do the actual request. Unless you've tuned up the number of worker processes, it's very unusual to see more than 3 nginx processes. Something is going wrong, or you are doing a hot binary upgrade. And yes, I did just say hot binary upgrade. Has anyone done the hot binary upgrade? 1, 2, 3. Was it cool? It was cool, yeah. It was definitely cool. So instead of stopping nginx, dropping connections, and restarting nginx when you make a configuration change, in this case, again, we're talking old school. If we're on VMs, if we're on hardware, if we're out in the cloud, you can stop an nginx process interactively, restart it. That's very much the restart Apache model. You can do a hot binary upgrade by sending a pup signal to nginx, which then will say this master will continue to excuse me, this master will continue to service all of the existing requests until they are gone, and we will start a new master process with new worker processes that will accept all the new incoming connections. And in most cases, except when you have exceptionally long-running, say, large content download processes, you have a seamless switch without needing to actually drop connections. There's a couple more steps in there, but that's the basics of it. It's still pretty snazzy. Just a couple more. Basic nginx commands, though. Reload, you can just reload the configuration file. Shutting down gracefully, shutting down fast. So the difference in a graceful shutdown and a fast shutdown is roughly like, hey, finish up the open connections and no stop now. It's a kill term, basically. The configuration file is, of course, where the meat of all of this is, and that's why we're going to spend the next roughly 30 minutes on configuration files. The main file is in nginx.conf, or is called nginx.conf, and it's located in etc nginx. Most of our documentation at nginx.org is directive-based documentation, so you almost need to know what you're doing, and then it'll tell you how to do it. It's not as easy to search. We've been working really hard in the last year and a half to build out more content on nginx.com that is more based on problem sets. So I really want to build a proxy server as opposed to how do I set this particular directive. But all of the directive documentation exists on nginx.org. And the configuration files themselves are built out of directives, blocks of directives, and then the context around them. So a directive is really straightforward. Directive is something that tells nginx what to do. Listen, port 80. It's about as straightforward as it gets. It's consistently a directive name, parameters, and then a semicolon. There may be multiple parameters, of course. There are simple directives and there are block directives. And the simple directives are the single line that can be generally used in different contexts. And I'll talk a little bit about context in a second. So far, is everybody tracking? Do I need more Apache to Nginx translations? Fewer? Don't care. Napping. Apparently napping. Block directives are sets of directives generally. So in this case, it is a set of configurations surrounded by braces that are grouped into a larger instruction set. So in this case, what we're setting up is the root location. So anything that comes into this block directive with just / is going to look in the root directory, which the root directory in this case is defined as user share nginx.html. That's a default in most of the packaged installs. And it also then looks for the default index file, which in this case, by default, is index.html. In this case, we're setting it to be index.html or an index.htm. So if you have the root directory and your index file, if you come into example.com / you don't give it anything after that, you're coming into example.com / index.html, which will be served out of user share nginx.html. Straightforward, right? Yeah. Okay. Block directives are directives that contain multiple configuration instructions. Hey, that looks like it's the same slide. There we go. Context examples. That's better. So a context example is a set of block directives. You see how I'm building this outward from a single directive to a block directive to a context example. So in this case, we are defining functionally a virtual server in Apache language. We say there's a location. At this location, we go to this root file system. At this other location, we could go to this other root file system. So here, if you go to example.com / index.html, it'll be served out of data.www. If you go to example.com / images.index or / index.html, it will be served out of /data. This all looks very similar. Specifying the server block, this again, virtual server, it goes inside the HTTP context. So we're again working our way outward. So we've got a single directive, we've got a block of directives, we've got a server block, and now the HTTP context itself is the entirety of the file generally. They can contain listen directives, including server names, as well as root directives for default. Now there is a whole series of inheritance in this, and you start with the HTTP context, and anything you define there can be generally overwritten. There are a couple of exceptions there, but almost anything can be overwritten the further narrow you go into server blocks or other block directives. So in this case, we will have the HTTP block, which can have multiple server blocks inside, and they can be set to listen on different ports. They can be set to listen with different names. You can define them by different names, as well as setting out your server directives in that space as well. Nginx will always choose to serve the process based on the most narrow definition it can match. So it will go all the way through the tree and do this most narrowly. So if you're using things like regexes or wildcards in all of this, the most exact and most narrow match is the one that will match. So I was saying that this is the most narrow match, of course. So inside a server block is the location block, which gives the matching context and matching configuration for your request URI. Any server block can contain multiple location blocks. It can contain and override root directives. It can contain and override index directives, different things like that. And you can nest locations inside locations. This can get really hairy really fast. And as I mentioned, you can have prefix locations or exact matches. You can also have regex matches. So, as an example, server and location. We have set this server to listen on port 8080. This is all static asset delivery. This is getting us really started for the more fun stuff. So the nap will be over soon. But I wanted to build from the basics on my way out. So the root directive here sets us for our default directory. We also set a location block with application 1. So this might be just more static assets for some reason, because we'll get to more interesting bits in a moment. Application 1 now has a new location for images. It also has a new location for a root file system for data. So if we're looking for localhost 8080, it'll return index.html from the home public HTML directory. If we're looking at localhost 8080/application1, it'll return from the /images directory. No, it'll go, that one I'm not sure. There we go. It will still come from index.public.html because we haven't actually gone into application 1 and we haven't said images. If we're looking for localhost 8080/images, then we will come into the data directory. The include directive makes this a lot less messy because you can actually, or maybe more messy, you can include further files. So you can include actual sub-files for particular virtual servers, much the way the best practices around Apache are. So you can, very simple syntax, include path to file. You can also include entire directories at the nginx.conf.d, for example, which is, again, pretty standard practice. You do want to generally define your server names here, and you can use wildcards in your server blocks. All fine and dandy. So that gets us static asset delivery at its finest, and occasionally most nested and complicated. But how many people deliver only static assets anymore? I'm going to assume no one, right? So that gets pretty boring. Oh, you do? Wow, we have one. We have one person who says just static assets. more often we see people delivering full-blown applications with application server backends. We see people proxying and caching with nginx. Very few people are just delivering static assets, although we're blindingly fast when you do. In a simple proxy scenario, we have a server listening for requests on port 80 and is serving content for any static assets. And then we have a server 2 that could be listening on port 8080 that could be running an application server, or in this case, we're going to pretend it's running an application server and is actually serving content from data proxy. These requests are then proxied if they come in from port 80 to location application 1. So this would be example.com/application1 would then be delivered, proxied, and routed to the server that is listening on port 8080 and delivered out of data proxy. Now, as I say, this is a kind of brain-dead proxy because you rarely proxy to another static asset, but sometimes it happens. Maybe you have multiple different applications or multiple sets of hosts that have different chunks of static assets, and you want to proxy across to them from a single place. But as you can see here, we have the server block set to listen on port 80. The default route for the highest level here is home nginx public HTML. The location / will pass to port 8080. The location application 1 will actually proxy pass to localhost 8080/other app. So there's a subtlety in this. If we come into example.com/index.html, it will actually deliver out of data proxy index.html. If we come into example.com/application1/index.html, then we will proxy pass to the /other app location. So we will actually be delivering out of localhost 8080 data/proxy/other app index.html. So anything that is appended after the top level domain is then matched, and that match is made, again, most specifically. So if you have a subdirectory there and you have a location that matches that subdirectory exactly, you deliver out of that location block. If you have one that matches inexactly with regex, that would be the second choice. And if you have one that doesn't match, it will be delivered out of the default, in this case, the proxy pass to just localhost 8080. Order does not matter. It is about the precision of the match. So again, it is the most narrow match, not the order it comes in. That would be even messier. This is a little bit more abstract, but that would be very messy, especially if you put includes in. Order does not matter was the question. So this is, again, the most specific match within the entire configuration file within the server block. Any other questions on that before I jump to logging? Yes? I don't know enough about CSS to say if it's kind of like CSS. So does somebody else want to answer that? Is it kind of like CSS from that perspective?
The specific you get, then that's what's going to apply.
That sounds correct. The more specific you get, the more, then that is when you apply. So it does sound like it is similar to CSS. Anybody else have questions? All right, let's go through some logging quick. So you should log things. This is an important starting point. The error log directive can be set anywhere in this. So it can be set at the HTTP layer, the server layer, the location layer, or context, and so on. You have a file and a log level as the directive variables, and it can be in the main, the server, the HTTP, and the location context easily enough. And the choice of what the log output is, the info level in this case, in my example, or debug, or warn, these are all have parallels within the rest of Linux. There are lots of different levels. Nginx binaries, as we compile them, don't generally have debug enabled, so it's hard to turn on debug in them. But you can, and you generally will be putting in a different binary for that. Logging best practices, of course, a separate log. Yes? Are we ever going to be able to use variables in the error log? I don't know. I haven't heard about that on the roadmap, but there's something in my brain saying that might have happened, but I don't think it has yet. So I don't have an answer for that is good, as far as whether or not there can be variables in the error logs. I can take that as a note, though, quickly, so that I can find that out. Variables error log. That's what I was thinking. It's like there's something in my brain that's going, I think we did that. We did have syslog support, but not variables yet? Okay. Oh, maybe that's what it is. Okay, so to repeat for everyone else, we're having a discussion as to whether or not you can use variables in the access log and error log directives, and I am going to check up on that, and it sounds like a great blog post for nginx, if nothing else. And we have a possibility that we can use it right now in access logs, but not error logs, so I will follow up on that. My apologies. Keeping separate error logs for each server is important. It keeps the log sizes tight, makes troubleshooting easier, pretty straightforward. You can aggregate them now using syslog, which is great. That was one of the first conversations that I had starting at nginx, was we had just implemented syslog in the nginx Plus product, which is the commercial product. And we ultimately, after hearing from the community, decided to port it back out to the open source product because we felt it was much more core to that. So it's now available in open source, and we are able to, you guys are all able to take advantage of it. It was, so just for a momentary digression on open source versus our commercial product, we want to put everything that is core to performance, scalability, and general content, good content delivery into the open source product. We want to put the nice to haves, the extras, the things that take a little bit of extra time scripting, or the things that you can find your way to if you use extra work or a third-party module into the commercial product. We want the core open source product to always be the super fast, reliable server that everyone has come to know and love and trust. So that gives you an idea of the philosophy of the differences between them. Okay, logging best practices, you should do them one per server. You can aggregate them in syslog. Fantasticness. How about questions before I jump onto proxying to an upstream, because we've got to hit load balancing, a little bit of caching, and now more Docker. All right, okay, then I will go on to proxying to an upstream block. This is taking the proxy capability and moving it to multiple servers. In this case, it's a load balancer. Fancy that. So we are defining a context block of my servers here, an upstream named my servers. It has 2 servers in it, and these servers are then being called whenever the server block below comes in and listens on port 880, gets a request for some sort of file. It's logged to the access or error logs, and then it is moved into the location, which is a proxy path up to my servers. Now, in this case, it's just built as a round-robin load balancer. It will go first to my server backend 1, second to my server backend 2. Now, if server backend 1 and if server backend 2 were DNS names themselves, DNS round-robins themselves, there's a gotcha here that in open source, the configuration file, opening the configuration file is the only time the DNS names are resolved. We have a feature set that we've worked on that is in the open source version, unless you are running your own local resolver, which let me put that caveat on. There's a way to do it, but it's more difficult. In the commercial product, we've actually made it so it resolves more regularly. But that's just a gotcha to know about if you're setting up those upstreams. It's better to make them singular. You can, however, go beyond just straight round robin. You can do things like weighted priority. In this case, this is just a weighted priority by ratio. So for every 5 connections backend server 1 gets, backend server 2 will get 3, backend server 1 will get 2. Again, pretty straightforward, nothing super exciting. These machines will also, if you have a connection and one of the backend servers isn't answering, will be dropped out of the load balancer until such a point as they answer again. And then there are some other fun features around load balancing that we've worked on within nginx+. I'm going to not talk much about that, even though it sounds like I may have already. If anybody wants to know more about those feature sets, let me know. We've spent time putting more features into some of the more complex bits with nginx+. Reverse proxy and caching. So on top of load balancing, which we recommend, which we use in conjunction with Apache in a lot of cases to do HTTP heavy lifting, connection aggregation so that you can have more connections into nginx than you could get into a single Apache server, and then making only connections out to the Apache server as you need. Also load balancing across different servers. We have reverse proxy capabilities that will also cache. So this is another very common way to work in conjunction with Apache, as well as in front of application servers of any sort. So the load balancing also works very well in front of application servers. People ask us about working with like Tomcat or UISKI or GUnicorn or varying Rails frameworks. All of these can be worked with both load balancing feature sets and reverse proxy and caching. So most of the content we see on the web today is dynamic, whether it needs to be dynamic or not. And as it turns out, one of my favorite things to troubleshoot many years ago was when people would have websites that were going all the way through this giant PHP application set and then all the way back down to a overloaded database just to pull out my name again and again and again. It turns out I'm probably not going to change my name in the next 2 minutes, much less 6 weeks. So, or 6 weeks, much less 2 minutes. So nginx is actually very helpful in reducing load to your application server and your database servers for things even with tiny amounts of caching. We've seen with things like WordPress sites where you can dramatically drop your application server load by caching as little as a second. So we recommend not only static content caching, but also tuning up and doing fine-tuning of dynamic caching or dynamic content caching as well. So setting up the cache path for this, you have to define a shared memory block in order to make this very cache. So in our HTTP server block, we define a proxy cache path, and that is where we store our cached content. That temp path puts the temporary data to build the cache, and then these all exist in the very large full server HTTP block. So this is per nginx master process, not per server block or location block or directive or location directive. This is for the entire running binary. So we actually have a key zone here defined as a 8 meg space with a maximum size of 100 megs. Key zone gives you the name and size so that you can reference it later. Max sizes don't get bigger than, and the inactive allows you to age things out of the cache. This is just a key value store, and then the cache actually exists. The cache actually exists on disk. Configuring the proxy cache here, the proxy cache key uses a full key of hostname, subdomain, and domain, and the request URI in order to give you a key. So it's the full kit and caboodle. And the proxy cache itself gives you the shared memory zone for caching. In this case, we see that the server cache, proxy cache is valid for 1 minute, and if it's not valid, we'll give you a 404. Passing headers in. Proxying and caching, if you're proxying to multiple hosts, you will find that it is whatever you have set as your proxy cache name, which we have here, unless you actually set your headers properly. So you need to make sure that you say proxy set header and then host, $host, which allows you to actually find the host that you are having conversations with as opposed to the upstream definition of the host. Proxy set header, X forwarded from, these are all important settings in order to see not just the reverse proxy, host, and IP. How about that? Proxies, really quick. More questions? One, yes? There is a third-party module that also works with mmcached. So is there anything that prevents it from not being stored on disk and being stored in memory instead? And the answer is there's a third-party module that can do that. It's not something that we've found needing to be done, especially as people move to SSDs. There doesn't seem to be, you don't get enough, we haven't seen enough of an advantage to make that. But there is a third-party module that allows you to work with memcached. Anybody else? Yes? Mm-hmm. Does creating a RAM disk help? There was an email about this on the mailing list that Igor answered, I don't know, within the last month. And I think the answer was, it's not necessarily worse, but it's not necessarily better because of the number of opens. But there was a good discussion about it on the nginx.org mailing list, so you may want to check there. Yeah. Other questions? You set an upper limit, sorry, the size of the cache. Is it dynamic or can you set upper limits? You allocate a minimum size, you set an upper limit, and then it's aged out by last used.
Can you set like a TTL kind of list? I wanted to stay there 1 hour.
There is not, can you set a TTL on the cache information? There's not a lot of granular cache manipulation available in the open source tooling. So it is just put it into the cache, and then when the cache actually no longer needs it or fills, it will expire it itself. In the commercial product, we have more granular cache management. Anybody else? Okay. SSL in 2 minutes or less? Okay, it's not quite 2 minutes, but it's getting close, because we do want to touch on that whole Docker thing, right? Enabling SSL by specifying SSL parameters. You set up a server block. Hey, we've seen these before, right? You set a listen directive. You say listen, in fact, on 443, because this is SSL. You give it a server name. The biggest difference here is you're adding certificates and certificate key files. This is what allows us to do that. SSL session cache can be stored, can be set up so that you don't have to have renegotiations on the handshakes as part of open SSL connections. There is also configuration for SSL stapling and OSCP stapling. I don't know enough about that to talk more about it. I know it's there. Mostly we know that we want to make this as straightforward and seamless as possible, reduce the amount of CPU and work that is done. And this session cache is also shared by all of the worker threads. So it's set up very similarly to the proxy caches, where you set it in the HTTP context, you share it across the different workers, and then you set a size for it. You also set a timeout on it. 1 megabyte of memory for the SSL cache can actually store about 4,000 sessions, and we've seen that to be linear. This can be set in HTTP or server context. Yes?
Not the cache. How is the cache organized so that I have a cache information space so that not have applications just people inside the cache?
I don't know that I can answer that. So how is the cache, we're talking about the SSL session cache?
Yeah, well, anything cached by the application.
Okay.
I don't want to just say I have applications that say that indeed what we cache.
Right. So the caches are generally key value pairs. So you have to look it up by key. And as far as more specific than that, like how it's ordered inside that and whether or not you have whether or not there is a way to actually go and break and read adjacent keys, that one I couldn't tell you. I would presume no, because we have lots of people trying to break this all the time, but that's something that would be a great question for the nginx.org mailing list. Yep, and that's so. I've mentioned it now a couple times. We have an open source user mailing list, which is nginx at nginx.org, and you can look for it at mailman.nginx.org to sign up for it. Bum, bum, bum. Now, with more Docker. I did get there. So nginx actually maintains a Docker Hub registry. Did anybody have more questions? I saw a hand. No? Maybe? Okay. Oh, that was yay, more Docker. Woo! More Docker. Okay. So nginx actually maintains one of the official repositories for, oddly enough, nginx. And we have built for this a Docker file that allows you to very easily build and run Docker images. So who here has played with Docker? Bits, everybody, okay. Nearly everybody, almost as many as us. Wow, in 2 years? Took us 10. All right. So everybody's played with it a little bit, so you're familiar with the idea of base images and then layers on top of those base images and then images made from those layers of so on. I have a picture of that in a moment, which we'll get to. This is the Docker file that we maintain. It's really straightforward. It starts from the Debian Wheezy base image, which is maintained by Ubuntu, I presume, or no, I'm sorry, Debian. We are defined as the maintainers. All it does is the stuff you saw earlier in my very basic install. It brings in the keys, it echoes where the sources are, it then goes ahead and sets some environment variables, pulls in the actual files, and then defines where we want to send logs, as well as defining a cache variable, exposing our hosts, and oddly enough, running as a command as a daemon nginx. So unsurprisingly, you get a little container that's running nginx, which looks, after you run Docker, like this. So this is mapping the ports that are available on the host Docker, so that's the big P, to the -D is the daemonize it, the Docker container nginx. Below that is my Docker container ID, and I can see with the Docker PS that I have a container running. This is exciting. I can't really do anything with it because I haven't put any configuration into it. I haven't made any changes to configuration files. I haven't given it any data, nothing like that. But if I go to my Docker host IP, and in this case, the mapped port of 49.145, which is mapped to 80, so you can see that right here. If I, in that browser window, I went to the Docker host URL plus that 49.140 or 154 port, I get my welcome to nginx page. Yay! We are back where we started on slide whatever that was. This Docker image is set with all of the information about it and a bunch of configuration information at registry.hub.docker.com with looking for nginx. If you want to dig in and actually look at this, so if you just run the Docker container, you don't get any sort of interactiveness, you just get port 80. But as a trick, to go look at what we do, you can run Docker run interactively and tell it to run a bash shell on that host. At which point you can go look at what the nginx configuration looks like for this, for our base Docker image. And that was great fun to do. Again, you stop it, it goes away. You disconnect from it, it goes away. You run it as a daemon, you can't actually connect to it on SSH. It's quite entertaining. So as I mentioned a little bit before, you've got this base image that was built in this case by Wheezy, or built by Debian for the Wheezy install. We built a Docker file that calls that base image to build our own image, which is the nginx image on top, having gone through that Docker file and given all of those different commands to do the install, as well as defining where a bunch of our files are, doing some installs of our software. This came from Jay Pataza's talk yesterday, great image, and then we published that out to the repository. What you guys get to do, once you actually pull down this Docker file, run it, take a look at the Docker container, and maybe even go in and look at configuration file inside of it, is you get to build your own. So going back one slide, you get to build another image on top. You get to build your own with your own data. You get to build your own with your own configuration files. So your Docker file might start with from nginx. So again, we're building on shoulders of other giants, or turtles upon turtles upon turtles. So we start with from nginx, and then we remove the default configuration files. We copy in some static HTML directory in the most basic case. Say we just want to run some static images. We have one guy over here that does that. And we bring in our own configuration file. Again, this is the simplest possible way to run, not necessarily scalable setup, but you've got a cookie cutter setup right now that can give you your static assets, the nginx.conf that you've defined in your Docker file directory, and you've got a nice repeatable process. Yes? So there is a default, that's the capital P. Do we have to take care of the port mapping ourselves when we fire up the Docker container as a daemon? So that's the Docker run -p-d nginx, and it will do a port mapping to allow the container's IP to be accessed from the host IP. Now it will be a random port. So you at some point would have to do some port mapping or some sort of proxying or load balancing to that Docker host's random IP. So in this case, it's the port of 49.154. Even though the container itself, the container IP, is running nginx on port 80. The Docker host will be running it, in this case, through its own mapping. And actually, Jerome talked about this yesterday. At one point they said, we'll just map them to the ports that they exist on. You know, so 80 will map to 80, 80 will map to 80. Turns out when you run multiple 80s, bad things happen. So they put it onto a random port, and then you need to put something in front or manage it in a different way, potentially linking other Docker containers in order to manage how to get it from the standardized ports. Yes? You can use the lowercase port and do your own manual mapping. Yes, but you can't do that by default. Yes, there is a flag with a lowercase p where you can manually map them. Yes?
One of the great use cases with nginx within Docker is doing something like that,
Mm-hmm.
and having nginx inside actually link to other containers and do your proxy. Should I go to the next slide?
Nope, you just gave me the fancier options cake, the cupcake on there. So we're running out of time, as I suspected we might be. There are a lot of other fancier ways to work with Docker. In this case, you can link containers to containers. You can run nginx within the within the Docker host so that it could proxy to containers. There's all sorts of fun composable pieces that are available then for you to move around. As far as best practices, I think a lot of that is still to be seen. Any other questions? Hands? Yes, sorry, hi. Yes, I was hoping I could get away without that question. No, HTTP2 support. Nginx was one of the early adopters of Speedy, and we actually are 94% of the Speedy traffic on the web right now. We are working on a plan to migrate our Speedy implementation to HTTP2 implementation because HTTP2 is based off of Speedy. So it is in the works, and I will go back to my earlier comment about roadmaps and how they might contain nuts. So I can't give you any exact dates, but expect some substantive update in the next couple of weeks in the sense of information, not in the sense of code. But we should have a statement on HTTP2 shortly. Yes? Say that again? Only if you're really nice. But yes, they'll be posted with the scale Hearts, yes. They'll be posted on the Scale website as soon as either I mail them to Shyam or somebody grabs me and reminds me. Other questions? Nope.
About let's encrypt. You guys working with EFF at all?
Let's Encrypt. I will have to go find out about Let's Encrypt. I don't know about this. So.
Good for SSL everywhere.
Oh, yeah. Well, so SSL everywhere as a concept is fantastic, and it really increases the bar of entry for people on the web everywhere. So at this point, we don't have any sort of policy as far as working with them on that, but it's definitely worth Let's Encrypt, or looking at Let's Encrypt. Anybody else? Awesome. Go forth and happy scale. Oh, wait, I'm sorry. One more?
What do you have against .html file?
It's not an HTTP standard. That's what we have against .htaccess files. All right, so with that trolling, go forth and enjoy Scale.